explode. No, it's not going to explode. Don't worry. So we're loading the coffee, and it's taking now 50 pounds. It's a very soft material, so it's going to take load very slowly. Remember that the stiffer the material, for the same strain, the more stress you have. So since we're doing this under control velocity, it takes load very slowly, opposite to the rock that was taking the load very quickly. So what we're going to do in this case is just to change the velocity so we don't wait here forever. All right, so I'll stop it, and then you press speed, and we'll go 10 times faster. So press down here. No, press digit, and then press up. And one more time. Yeah, that should be okay. That's going to be 10 times more than what we had before. Just speed again. And now press up just one time. Okay? All right. Now it's taking low very quickly. It's going 80, 90. And those of you that are close to the coffee, you may see how it starts to deform. But it's already taking 100 pounds. And it's increasing, starting to deform. I don't know if you can see, but there are some bands over there. But now we have about 200 pounds, 160 on this package, okay? So anyone thinks it's gonna take more load or less than what I said? A little more? Okay. How much more?
400.
400? But that was my number, 400, wasn't it?
You said 360.
360? Okay. Okay, it's already at 230. And still taking load, still increasing, right? What's your name?
Joe.
Joe? So it's still increasing, right?
Yeah.
So I'm not lying.
260.
Okay. And how does this look over here?
Looks good.
It's still increasing, right? It's very clear from the curve. When you check the videos, guys, you will see that we're looking here at the curve and it's increasing steadily. So if we had displacement plot versus load, that will allow you to measure the Young modulus of this material. It's very linear so far, and because it is linear, also it's telling me that it's not failing. Okay, so 340, and I think I might be falling a little bit short of my prediction. Anyone think it's gonna take 500, 600? Okay, it's 380, and let's see over here.
Still looks good.
Still taking load, right? Linearly. Okay. $400. Anyone has a razor knife or something like that? Here? No? No? No, like pencil? No, I think we need something stronger, but a sharp key. 400, 450. Okay, let's see what you get. Okay, this is still taking load. All right, yes, this is gonna be tough. Let me borrow. Okay. So, no, it's gonna be okay. Don't worry. 480. I'm stabbing
No, don't do that.
yeah, I'm stabbing. Okay, we're already at 500, guys. 500. That was more than what I thought. Are you sure the area is correct, right? Okay. Okay. I wouldn't touch it right now because it may go sideways. Okay. So 520, and it's starting to show some variations of the load, right?
Yeah, right there.
And I don't know if you would agree with me, but it's kind of like starting to level off.
Yeah. Yeah.
Before it was very linear, and now it's starting to curve. So it means that it's not taking load at the same rate that it was before. So we'll just load a little bit more, and we'll see how much we can get. We're going to see later on that in order to do this kind of test, sometimes our sample has to be 2 times the diameter. So this one, at this moment, it might be falling a little bit short on that ratio. It's too long in one direction to fail in the way I want it to fail, which is in shear. All right, so we are at 600 and I start to hear some noise. Do you hear the noise, Joe?
Yeah. It's like
Okay,
back.
okay, we'll stop it now. Just stop once. So it's
Should we
making some
speed it
noise.
up?
No, let's just keep it there. So it's what's happening with the load? Miss, what's your name?
Darian,
Darian, what's happening with the load?
it was starting to level off.
And right now,
It's
right now
going
it
down.
drops.
it's
dropping.
increasing, right? So we have now stopped the loading, and the load is decreasing. That's the stress relaxation, if you remember what we discussed before. That the load actually doesn't have to have stress anisotropy, stress in different directions, so that it's starting to relax. All right, so now I'm going to stop it, and you'll see. What do you think is going to happen when I stop the sample?
For the load.
Why would it collapse?
Do you want me to start it again?
Oh, you stop?
Yeah, when you said stop.
Oh, okay, I'm sorry. Yes.
Okay.
No,
Oh.
well, no, okay, that's okay. We'll see. Hopefully the data is not. So what do you think is going to happen?
It's gonna spill out everywhere.
Okay, so let me tell you, inside there is coffee, okay? So don't worry, it's not going to spill any water or oil. It's just going to be coffee. But notice that we are able to put 500 pounds in here just because of the confining stress, because we have atmospheric pressure around. Inside the package, there is no pressure, there is vacuum. So around all this sample, we have atmospheric pressure. We have 15 psi. And now we're applying with the load frame 471 divided by more or less 8 square inches. That would be about 60 psi, right? So we have 60 psi in axial direction and around the sample 15 psi. Well, when I take this 15 psi off the material, it won't be able to resist any force at all. And actually, if we look at that plot over there, instead of being able to resist a radial stress on which will be the left leg of the circle, and an axial stress, which will be the right leg of the circle, because the left leg is going to be at 0, the load is going to go immediately to 0, okay? So can you verify that, John? So I'm going to stop it right now. And also, please be silent, because this is going to make a noise. Can I go here? Can you come over here? Sorry. I want to record the noise of that. So I'm going to stop it here from the side. And it's going to be the noise of the air getting in, okay? So don't make any noise. And what is the load? Still holding a little bit because of the package, but let me stop a little bit more. Did you hear the noise?
Mm-hmm.
So that's the air getting in. And if now it's just the strength of the membrane, which is holding the coffee, and when I take this out, the load, what is the load, Joe?
56.
56, so it's just very small. If I were to open on this side too,
It's a 10.
it's 10 or it's virtually 0. And what I want you to notice is what we had inside. So inside, we just have ground coffee with no cementation at all. What was holding all that force, all that stress, it was just friction between grain to grain. And that's that line that we see over there, the friction line that gives materials shear strength. This is why when we apply a pressure through a mud cake, we're able to drill wells in uncemented sand, because the mud cake is applying a stress similar to what this membrane is applying to the coffee. But this is just, these are coffee grains, okay? And the stress went to zero. Okay, good job.
Thanks.
Thank you. Any questions about these guys? No? All right, so let's see, what time is it? Let's talk 10 minutes about the theory, and then I'll let you go, all right?
Thank you.
All right, you're welcome. Thank you very much.